channel. Today's topic is latitudes and longitudes. The earth is not a sphere. It is slightly flattened at the poles and bulged in the middle. Can you imagine such a shape? Well, if not, you can look at a globe to get a slight idea of how the real earth looks like. A globe is the miniature model of the earth that shows all the continents, seas and oceans in their exact same place but smaller and reduced down to scale. A globe, you can simply call it a representation of the earth. Well, if you look at the globe closely, you will notice that a needle is passing through the globe that helps it to spin from east to west, just like the earth would do around its axis. But remember that the real earth has no such needle. The earth just spins around its axis, which is an imaginary line, by the way. It is difficult to point out a location on the globe and describe exactly about it. Now the question arises, how to locate places on the earth? For this, we need a reference of horizontal and vertical imaginary lines that are going to help us to locate different kinds of places on the earth. These are known as latitudes and longitudes. So, let us first start with latitudes. Latitudes are horizontal imaginary lines that run in a circular manner. There is an important latitude known as the equator. The equator divides the earth into the northern hemisphere and the southern hemisphere. The equator is a latitude that is marked at 0 degrees. In the northern hemisphere, there are 90 latitudes. In the southern hemisphere, there are also 90 latitudes. And all combined together, there are 180 latitudes in total on the earth. So, there are 5 important latitudes, including the equator. So, let's learn about them. For this, so that you can understand easily, I have made a chart about latitudes here. So, the circle represents the earth while the horizontal and vertical lines represent the latitudes. Okay, they're just horizontal, not vertical for now. So, this line that you see, this latitude that you see is the equator. The equator, as I said, divides the earth into the northern hemisphere and the southern hemisphere. So, above the equator, there is another latitude, this latitude, that is known as the Tropic of Cancer. The Tropic of Cancer is marked at 23.5 degrees north. So, above the Tropic of Cancer, again, there is another latitude, this latitude, known as the Arctic Circle. The Arctic Circle is marked at, the Arctic Circle is marked at 66.5 degrees north. So, both the poles, the North Pole and the South Pole, are also counted as latitudes. So, the North Pole is a latitude that is marked at 90 degrees north. Overall, in the northern hemisphere, there is the Tropic of Cancer, the Arctic Circle, and the North Pole. But coming down to the southern hemisphere, below the equator, there is this latitude that is known as the Tropic of Capricorn. The Tropic of Capricorn is marked at 23.5 degrees south. And below the Tropic of Capricorn, the last one, which is the Antarctic Circle. The Antarctic Circle. This is the Antarctic Circle. It is marked as 66.5 degrees south. So, just like I said, the North Pole is a latitude marked at 90 degrees north. The South Pole is also a latitude that is marked at 90 degrees, 90 degrees south. So, these were the 5 major latitudes: the equator, Tropic of Cancer, Tropic of Capricorn, the Arctic Circle, and the Antarctic Circle. So, all these latitudes help us to locate places on the earth, and at the same time, they help us to understand about different kinds of time zones. So, let's learn about the different kinds of time zones now that we have learned about the major latitudes. There are 3 different kinds of time zones: the torrid zone, temperate zone, and the frigid zones. These zones are the 3 zones on the earth. So, coming back to the chart, here, this is the equator, the whole thing. So, this is the equator, and The torrid zone. Let's learn about the torrid zone right now. So the orange part that you see here in the northern hemisphere as well as in the southern hemisphere. The orange part that you see, it resembles the torrid zone. The torrid zone is the hottest zone there is. It's the first zone and is the hottest zone there is because of the tilt of the Earth's axis. The sun's rays fall directly on this region, giving it the most heat and making it the hottest region on the Earth. So the next zone is the temperate zone. Back to the chart. So the green part in the northern hemisphere, the green part in the northern hemisphere and down here in the southern hemisphere. The green part resembles the temperate zone. The temperate zone has moderate climate. It is neither too hot nor too cold. So the climate here is moderate and it is known as the temperate zone. The last zones are the frigid zones. The frigid zones are the blue part that you see here in the northern hemisphere and the blue part that you see down here in the southern hemisphere. They are the frigid zones. The frigid zones are the coldest zones there are because this is also because of the tilt of the Earth's axis. These regions receive the least of heat, making this region the coldest region, the coldest zone. The coldest zones, both in the northern hemisphere and the southern hemisphere. So these were the three types of temperature zones: torrid zone, temperate zone, and frigid zones. So with this, we have learned about latitudes. So let's move on to longitudes. So we need, for locating places on the Earth, we need to know more than latitudes, which is why we have longitudes. Here is another chart that represents about longitudes. Longitudes are semicircular lines. They are semicircular imaginary lines that help us to understand about the different kinds of time zones on Earth. Latitudes help us to understand about temperature zones, while longitudes help us to understand about time zones. So they help us to understand about time zones. Longitudes are measured in degrees of longitudes. And each degree is further divided into minutes, and minutes are further divided into seconds. So the longitudes are also known as meridians. Unlike latitudes, longitudes are all of the same size. As you can see here, they are all of the same size and they are vertical. So they are all of the same size. So it was difficult to know from which longitude or meridian the countdown should begin from. So all countries agreed that the countdown should begin from a longitude that passes a place called Greenwich in London, where the British Royal Observatory is located in. So all countries agreed that from that particular meridian the countdown should begin from. This was named as the prime meridian. The prime meridian divides the Earth into the eastern hemisphere and the western hemisphere. The green line here is the prime meridian, which divides the Earth into the eastern hemisphere and the western hemisphere. So the prime meridian passes a place called Greenwich in London, this is why it is also named as the Greenwich, which is why it's also named as the Greenwich meridian. So longitudes help us to understand about time zones. The time zones, great, let me read the chart again. So the longitudes help us to understand about time zones. This is the prime meridian. So the places, the regions near the prime meridian, the time zones of those particular regions are known as the Greenwich Mean Time, named after the meridian. So they are known as the Greenwich Mean Time. In the eastern hemisphere, there are all the 1 to 180 degree longitudes. And in the western hemisphere, there are also all the 1 to 180 degree longitudes. But at the 180th degree longitude of the eastern hemisphere and the western hemisphere is the same. This is because both the longitudes lie in the same part, making them one. So this meridian is also known as the 180th degree longitude of east and west. So the International date line lies on this meridian. So, longitudes help us to understand about time zones for the millionth time, but leave that for now, just get to it. So, longitudes help us to understand about time zones. And when we are traveling from the prime meridian, when we are traveling eastwards from the prime meridian, for every 15th degree latitude, we need to add up 1 hour to know the current time. Because the earth has 24 different time zones. So the time zones are different in each of the places. So when we are traveling eastwards from the prime meridian, we need to add up the time for every 15th longitude, for every 15th meridian or longitude. But the opposite happens when we are traveling westwards, away from the prime meridian. When we are traveling westwards, we subtract the time. For every 15th degree, we subtract 1 hour. Doing this, we can understand the current time of the local place that we are in. So the best way of measuring time is by noticing the Earth's movement around the sun and around its axis, and also by looking at the moon and planets. Yes. So the sun rises and sets regularly. Naturally, it is the best timekeeper in the world. So local time can be told by looking at the positions of the sun or the shadows cast by the sun, which are the shortest in noon and the longest in sunrise and sunset. So local time can be told this way. But speaking of time zones, why do we have standard time? This is because local time is bound to differ when when the local place is lying on various kinds of meridians. For example, it is difficult for keeping a timetable for trains that cross several meridians. It is difficult to keep a timetable for them. In India, for instance, there is a time difference of 1 hour 45 minutes from Dwarka in Gujarat and Dibrugarh in Assam. There is a time difference of 1 hour 45 minutes. And this is why it is important to adapt to the standard time of the local place. And in India, the 82.5 degree east longitude is known as the standard meridian for India. It is also known as the Indian Standard Time or IST. So this brings us to the end of today's video. We have learned about latitudes and longitudes, and so this brings us to the end of today's video. So that's it for today. Until next time, I am Aradhya. I'll see you in the next video. Bye bye.